Welcome to ClickMyProject.com. Now we discuss about the product objective quality assessment for color to grayscale image conversion. Now we discuss about the abstract for the process. In this paper we present a new algorithm to transform an RGB color image to a grayscale image. We propose using C2G, that is the color to gray structural similarity SSIM technique to map higher dimensional color vectors to lower dimensional ones. This approach generalizes the gradient domain manipulates for high resolution images. Our experiment shows that the proposed algorithm generates competitive results and research a good comparison between quality and speed. In the existing system, C2J conversion seeks a preserve color distinction in the input color image in the corresponding grayscale image with some additional constraints such as global consistency and grayscale prevention. In this project, the system proposed a C2G structural similarity index, that is C2G SSIM. It evaluates the illumination, contrast and the structural similarity between the reference color image and the C2G converted image. To explore the potential of the C2G SSIM, we further demonstrate its use in two applications: automatic parameter tuning for C2G conversion algorithm and the adaptive fusion of C2G converted images. Now we discuss the flow diagram for the process. At first, the input image is taken from the dataset. The dataset is nothing but the folder which consists of the several images which is undergone for the process. After getting the input from the dataset, the grayscale conversion is carried out. This grayscale conversion is the initial grayscale conversion and the color space transformation is carried out for that grayscale image. In the color transformed image, the luminance comparison, contrast comparison and the structure comparison is carried. These three are the major module for the color space transformation. After these three modules, the combining the components are carried out. The combining the component is nothing but the concatenate these three actions, and then the color to gray SSIM image is the final output from the combining the three channels. After getting the grayscale image, the quality of the grayscale image by the input image is analyzed. Now we discuss the initial running procedure for the process. At first you can see the several files in the left side in the current directory. Select mainfile.m and then right click in that file. You can see the several options. In that you can select the option run. Now the dataset folder was opened. In that you can see the images in the dataset folder. Select any one image from the dataset and click the button open. Now the process is going on. Now the input image is shown in the figure 1 with the title input image. The input image is the color image, that is the RGB image. Then in the second image, that is the figure 2, the filtered image is shown. In the filtered image, the noise removal is carried out. After the filtering process, the grayscale conversion is carried out. In the figure 3, the initial grayscale conversion is carried out and the grayscale image is shown in the figure 3 with the title grayscale image. Then we have to separate the channel from the RGB image. Now the red channel image is shown in the figure 4 with the title red channel image. After separating the channel from the image, the grayscale image is shown in the figure 5. Then the illumination correction and the saturation values are calculated and the respected figure is shown in the figure 6. These are the clustering formula of the corresponding to the color values. Then the hue saturation values are shown in the figure 7. These are subplotted in the figure 1 and 2 and 3. Then the luminance, chrominance and red chrominance are shown in the figure 8 with the subplot of first image, second image and the third image. The first image shows the luminance and the second image shows the blue chrominance and the third image shows the red chrominance. After correcting the all luminance and chrominance, the luminance chrominance corrected image is shown in the figure 9. Then the resultant grayscale image is shown in the figure 10. These have the qualities which is similar to the figure 1, which is nothing but the input image. Then the corresponding histogram values are shown in the figure 11 and the figure 12. The figure 11 represents the histograms of the figure 10 and the figure 12 represents the histogram of the original image. Thank you.